This is a demonstration of using the calculator in all the stages of analyzing the relationship between two variables as detailed in Chapter 8. So this is page 197, number 41. And in answering this question and all of these questions, I'm going to be referring to the practice, the step-by-step example found on page 185. And so we're in the think step here. Think, state the problem, and determine the role of the variables. I am interested in the relationship between age and price of used Toyotas. I'll use age to estimate price. Right? It's price versus age. Okay, so we're going to talk about the quantitative variables condition. I have two quantitative variables. Namely, age, whose unit is years, and price, whose unit is dollars. Years, comma, dollars. Okay. Measured on, and count them. Let's go back to the problem. Measured on 13 Toyotas. Okay. Now, if we go back to the step-by-step business here, we'll see that the next thing we got to do is check the conditions for regression by making a picture. So now we'll go back to the problem. Look at the calculator, and we'll make a picture. And I'm going to pause here while I do that. Make sure you note that the data for the years is 1, 1, 3, 4, 4. In other words, it's not 1 through 13. I made that mistake when I put it in, and I had to go back and fix it. So just study carefully what the year data is. The prices, I'm sure you'll get right. All right, so I got my data put in, and here it all is. Now I'm going to do second. First thing, yeah, I'll do second and y equals. I'm going to turn on scatter plot, which is this icon right here. If it's not turned on, I arrow down to it, hit it on. Now, I'm set to L1 and L3, and I want to do L1 and L2, so I'm going to do second and 2 and enter. Okay, then I'll do zoom and 9. Okay, now I have my association. I can go back. I'm going to go back to answering the question and the rubric for answering the question. Okay, and I'm going to put the calculator picture somewhere where I can see it. So let's go over here. And outliers. No outliers. Is it straight? Well, let's talk about the association. The association is straight, negative, strong, with no outliers. Does it thicken? That is, does it spread outward or inward? Does not thicken. So I can therefore go ahead, let's look at this here, check the conditions. If there are no clear violations of the conditions, fit a straight line model of the form y hat equals b sub 0 plus b sub 1x to the data. Now you're going to do that. Now we're not going to list all these things that they have over here. It's not, you don't have to do that. Well, let's do it right now, at least for this problem. It's an interesting exercise. But the calculator is going to actually do all the work for us. To get all this information, we have to do a few things with the calculator. So let's get the calculator. Let's start taking some pictures. So I'm going to take a picture. Oops, I'm going to get rid of buttons. Let's go back here. Let's take a picture of this. Okay. Now, I'm going to do, first I want to make sure that diagnostic is turned on. So I'm going to do second and catalog. Now, you don't need to do this if you haven't reset your calculator recently. But if you're sharing with somebody, then you may want to at least just run it to be sure. Now you'll know if it's not turned on because you won't get correlation when you run linear regression. Okay, so let's clear this, and we're going to do stat calc 8. We default to L1 and L2 because that's what we're using. So I hit enter. Now, you'd want to write down at least a shortened version of these. I'll take a picture of them so I don't have to bother. But you should know that these variables are also stored inside the calculator in an area that's very easy to get to. I'm trying to fix this thing here so it's not so big. There we go. Alright. Okay, so now where do I find, so here's R. Now let's do the other stuff first. So they want to know, at least just for this one problem, we're going to do y bar s sub y, x bar s sub y. So how are we going to find that? Well, we'll go to the calculator. And I took a picture of this, so I'm going to clear it. And I'm going to do stat calc, single variable stats. And first I'll do it on L1. It defaults to L1. L1 is the x coordinates. So I hit enter, and this is all I need. I don't need to know the 5-number summary. All I want to know is the mean of the x-coordinates and the standard deviation of the x-coordinates. Well, that's what this window is. The mean of the x-coordinates is 6.13. Let's write that down. X bar equals 6.13, and S sub y equals, S sub x. Set the standard deviation of the x-coordinates, we'll call it 3.78. Okay, now I'm going to clear this, and I'm going to run stat calc 8 again. Now I'm running it on L2. Now here's something that's confusing. Notice that the calculator calls everything X bar. Okay, there's always going to be this somewhat slight or not so slight disconnect between what your calculator calls stuff and what you're going to call stuff. Okay, what's X bar in terms of the calculator, it's easy to tell the difference, is the average of the Y coordinates. So you're going to call it Y bar equal 8403.8, and the standard deviation of the Y coordinates is approximately 3.3. Call it 0.6. Okay, so we have correlation. I didn't write it down. Let me write down correlation. Okay, and R equals 0.972. Let's call it that. Okay, so we can actually use this to calculate B sub 0 and B sub 1. So B sub 1, B sub I, B sub 1 equals, this is in the model Y hat, equals B sub 0 plus B sub 1 times X. B sub 1 equals 0.972 times standard deviation of Y, 3.3336, divided by the standard deviation of the X coordinates, 3.78. This is going to be a pretty big number. So it's approximately equal to, let's do this in the calculator and see how well it compares to what the calculator actually said it was. So I'm going to clear this. 0.972 times 3.6 divided by, what's that number? Can't even read my own handwriting. 3.78. Oh. 3.78. Okay, 857 approximately. So it's approximately equal to 857.2. And 857.2. Standard deviation. And to see where I made a mistake in my calculation, I had copied down the standard deviation of the X coordinates as 3.78. It's really 3.38. Of course, I had the correlation as positive instead of negative. So B sub 1 equals negative 0.972 times 3.336 divided by 3.38. That will give me my right answer, I believe. So negative 0.972 times 3333.6 divided by 3.38. And that's pretty close to what the book has. So that's B sub 1. So how do we find B sub 0? We plug in y bar and x bar, and into the formula. So y bar equals b sub 0 plus negative 958, call it 0.7 times x bar. So y bar, which is 8403.8 minus negative 958.7 times x bar, which is 6.13, equals b sub 0. Now let's see how close this is. So 8403.8 now we got two minuses, so it makes a plus. Times 6.13, and that's pretty close. So price, the estimated price equals 14280.631 dollars minus $958.7 times age in years. So this is price in dollars, age in years. And this is how the finished equation is typically written with contextualized variables. So this is read, estimated price in dollars equals $14,280.631 minus $958.7 times the age in years. Now, what's the meaning of this number right here? This is the age. This is the price of the car when it's new, when its age is 0. And what's the meaning of 958.7? For every increase of age in 1 year, the price, the estimated price, decreases by $958.7. Now, we're not out of the woods yet. Okay, we wrote our line of best fit, but we have to check the scatter plot of the residuals. Okay, so how do we do that? We'll go back to the calculator. Now, the residuals are stored inside the calculator in a list called ResID, which you can get the name for this list pretty easily. But here's what we're going to do. We're going to do second and y equals, and we're going to go back into our scatter plot. And we're going to do the residuals versus years. So we'll leave L1 as the X list. And for the Y lists, we're going to go to second and hit the stat key, and that puts us in the list menu. And if you've run linear regression with diagnostic on, then you produce residuals. So you hit 7 and enter. Okay, and now we're going to hit zoom 9. Now here's the residuals. Now, do you have an up and down pattern? You mostly do. It's not great. it's not completely random, but it doesn't have a real noticeable curve in it. So the residual plot looks okay. So the scatter plot, let's go back to our rubric here. Now, they have a little discussion of R squared here. They actually don't discuss it. We'll get to that in a minute. But R squared is simply correlation squared. Now here's your conclusion. Do they talk about... They do not talk about residuals. Let's talk about residuals. Now, if you were answering this for real, the only thing that's different is you would have drawn a picture of the scatter plot, and then down here you would draw a picture of the residuals, just a brief sketch. This is the last precondition. The residual plot is random enough to allow correlation to describe the relationship between price and age for used Toyota Corollas. Man, should have put that in at the beginning. Alright. This should have been put in at the beginning. Toyota Corollas. My mistake. Okay. Now, R squared, which is for some reason written with a capital R, equals, let's go back to the calculator where I have all this stuff stored, and you would have written it down, equals 0.97, let's call it 0.972. What does this mean? 97.2% of the variation of price is explained by variation in age. As shown in the model. About 2.8% variation of the variation is not. Okay. And so, in addition to this and describing what the variables mean, then you're done.